Hi, my name is Shweta Nayak, and I'm a program manager with the Azure Cosmos DB team. And today I'm going to talk about migrating to Cosmos DB's API for MongoDB from a self-hosted MongoDB instance. So here's what I'm going to talk about today. The benefits of migrating to Cosmos DB, why you should consider this migration. I'm going to talk about a pre-migration checklist, things that you need to take care of or plan before performing the data migration, and the common migration methods. So I'm going to cover three methods today: the database migration service, the native MongoDB tools, and the Azure Data Factory. I will talk about the considerations and also demonstrate how we can use each of these three methods. And lastly, I'm going to talk about the post migration steps, which is the steps that you may need to perform to completely move over your application to Cosmos DB from your self hosted instance. So, why should you consider migrating to Cosmos DB? These are the few reasons, but the first one is scalability. You get virtually limitless data and throughput scale out with Cosmos DB. You also get features like auto scale, with which you can granularly scale up and scale down, and you can set throughput at database or container level. You can configure your data to replicate globally across 60 plus regions with multi region replication. With multi-region replication, you're also guaranteed to get 5 nines of SLAs for read and write availability. Lastly, there is no management overhead involved. Cosmos DB is a managed service, so everything like provisioning, configurations, patching, infrastructure management is taken care of for you. There is minimal setup and administration needed, so you can focus on developing your application rather than managing the uptime of the database. So the idea is you leverage your existing MongoDB drivers and tools and libraries and still use a multi-model globally distributed Cosmos DB database. So for today's demonstration, I'm going to use an application called Mflix. This is an open source application. And yeah, this is how it looks like. It is a MERN stack movie catalog application, and it is currently deployed against a self-hosted MongoDB instance. By the end of today's session, I'm going to move this application over to Cosmos DB database using Mongo API 4.0. So let's talk about the pre-migration checklist. These are a few things you need to consider and decide before you perform your data migration. So the first thing is to choose the MongoDB API version based upon the supported syntax and features. So currently we support three API versions with Cosmos DB, 3.2, 3.4, and 4.0. The syntax and features for each of these versions is clearly documented in our articles. So depending upon the kind of queries you're performing, the API version that you're using in your self-hosted instance, you can decide which API version to migrate to. You should prefer to migrate to an API version where you need no or minimal change to your application code. The next important thing is to estimate the throughput needed for the application. Again, this depends upon the number of requests that you're performing, the charges for each request, and the type of queries you're performing. You need to pick the right partition key. Choosing right partition key is very important in Cosmos DB because once a partition key is chosen, it cannot be changed. So you should aim to choose a partition key with high cardinality and one that avoids hot partitions. You also need to decide the best indexing policy for the data. Some indexing policies are not supported in Cosmos DB, so read up, check what your existing policies, indexing policies are, and decide what works best for you while moving to Cosmos DB. Now, the indexing policy can also impact your performance and the charges significantly. So, picking the right indexing policy is also very important. So once you have these things in place, keep the destination Cosmos DB account ready with the right API version that you need to migrate to and the region. It could be a new Cosmos DB account or an existing account that you have. And lastly, you need to choose the migration method. Like I said, I'm going to talk about three migration methods today: the database migration service, native MongoDB tools, and the Azure Data Factory. And I'll be talking in more detail about the considerations and demonstrate how we can use each of these services to migrate the data set from self-hosted instance to Cosmos DB. So let's start with the database migration service. Database migration service makes use of the Cosmos DB bulk executor library. This is an open source library managed by Microsoft. We have online and offline mode available in DMS. It takes care of replicating live changes in online mode. So both the modes perform snapshot migration. The difference is in online mode, it'll only migrate the data which was available at the time of migration, whereas in the online mode, it will migrate the subsequent data as well. Online migration is supported in premium tier, and premium tier is free for the first 6 months. The standard tier with the offline migration is free for up to 4 cores. And DMS is suitable for large data sets. So what I'm going to do next is to walk through the migration for a sample dataset using database migration service. So these are the steps involved: creating database migration service, creating the migration project inside the service, creating the activity inside the project, and then how to monitor the status and progress of the migration. So I'll switch over to my Azure portal here, and this is the Cosmos DB target account to which I'll be migrating over the data. As you can see, currently I do not have any databases. This is an empty Cosmos DB account. And by the end of today's session, I'm going to be having 3 databases over here migrated using each of the 3 migration methods. All right, so let's look at the database migration service first. So I'm going to create the database migration service resource over here. I will choose the resource group to which I want to deploy this service. I'm going to name the service Migration Mongo to Cosmos 1. And I'm going to choose the location as Central India. Central India is the location of my target Cosmos DB account. This is my target Cosmos DB account. It's located in Central India and runs Mongo API 4.0. My source is also in Central India. It is recommended to create the migration service in the same region as the target for optimal migration performance. All right, so I'm choosing Central India for that reason. And I have 2 options for the pricing tier. I'm going to switch to premium because I want to perform an online migration, and that's available only with the premium tier. So I'm going to click next, and here I get to choose the virtual network, which will be used to talk to the source data set for migration. So I'm going to choose my VNet and review and create the service. Yeah. So typically this service is going to get deployed, and then it's going to take some time to get into an online state to be ready for us to perform next steps of the migration. So I have an Azure database migration service resource already created for this demonstration. So I'm going to use this resource, and here's how the other resource will also look like once the deployment is completed. The status should be online, and once it is in a ready state, we can create a new migration project. So I'm going to name the migration project MIG1, and the source server type I'm going to choose is going to be MongoDB in my case. And with MongoDB as the source, the target server can only be Cosmos DB Mongo API, so it's already populated. The migration activity type that I want to perform is an online data migration. So I'm going to switch to online mode here. And this is the wizard for creating the new migration project. Once I click on create and run activity, it is going to take me to the wizard for creating the migration activity. All right, so this is the migration activity creation wizard. There are 5 steps over here. The first one is selecting the source database. So I'm going to choose the connection string mode to connect to the source database because this is the most straightforward. And I'm going to put in the connection string of my source MongoDB database. So here's the username, password, the public IP address of my self-hosted Mongo instance, the IP on the port on which the service is listening, and the database against which I'm authenticating. I'm going to select next, and in the background, it is going to make sure the connectivity to the source is available, and it's going to take me to the next step, which is to select the target database. So my target is the Cosmos DB account. So I'm going to go for the first mode here, selecting Cosmos DB target and the subscription, and I'm going to choose the target Cosmos DB account that I intend to migrate to. And as you can see here, the connection string for the Cosmos DB account is already populated, so that's great. I'm going to click next, and once again, it's going to verify connectivity to the target database, and it's going to get the list of databases available for migration from the source. So in my scenario, I have one database on the source, and as you can see, that has been um, um, pulled over here. And I need to select the database that I need to migrate. I can specify the throughput at database level. So in my pre-migration phase, if I had decided to specify throughput at database level, I can do that over here. And with cleanup collections checkbox, if there is any existing data at the target, it'll be wiped out and replaced with the migrated data. So I'm going to leave the settings default over here and going to click on next, which takes me to collection settings. So here it has retrieved the list of the collections available for migration from the Mflix database that I picked. Right, so I have 5 collections over here, and once again it has picked some default throughput and the shard key for each collection. Once again, depending upon what you have decided in the pre-migration phase, you can change these values or leave them as is according to your requirements. So I'm going to proceed, and that'll take me to the migration summary, where it'll show me the summary of the target server name, the target server version, the source server name, and the source server version. DMS also has the checkbox to boost RUs during migration. So it's automatically increase the RUs and drop down later just to make sure the migration completes faster. I'm going to give the activity a name here, and I'm going to start the migration. Yeah, so the migration process has begun, and as you can see, this migration service did not have any projects inside it. Now it has a project which I just created. So I can click on that and view the status of the details of the project. And inside the project, there's an activity. Activity could be a bunch of database migrations that you're performing together. So I can view the activity status over here. It's still running. And I can click on the activity and get more details about the databases which I have picked in the activity. So here's my database, and as we speak, the migration has already completed. It shows the stats about the migration, the data transferred, and the duration, the documents processed. And once we click on the database, we can also view the statistics at collection level. Right? So this gives the whole view of the migration progress and the status. And since it has now completed, let's go back and check on the target database. We should see the database and collections populated here, and there it is. So we have the sample mflix database added over here with all the 5 collections and data inside each of them, right? Perfect. So that's about the database migration service. Next, I'll be talking about the native MongoDB tools. So for people who have been working with MongoDB for a long time, might find or find these tools very familiar and may prefer to use these tools. These tools are also easy to set up and integrate. So we have utilities with MongoDB like MongoDump and Mongo Restore. These produce the exports in BSON-based binary format. We also have commands like Mongo export and Mongo import, and these produce the output in JSON or CSV-based format. Mongo dump and Mongo restore are typically faster and can be used to dump and restore entire databases. Export and import have the advantage that they can be used to migrate a subset of data. So you can specify queries to filter out some of the data and migrate only that subset, right? The good thing is these tools can be used with clients like Mongo Shell, as well as other clients like Studio 3T, Mongo Robo, and many more. So I'm going to quickly demonstrate um, both of these tools, Mongo Dump, Mongo Restore, and Mongo Export and Mongo Import. So for this demonstration, I'm going to switch over to the terminal. This terminal is connected to the self-hosted instance of MongoDB that I'm running. And this machine already has MongoDB, Mongo Shell, and the utilities installed. So I'm going to be able to use all those commands from here. Let's first look at a sample Mongo dump command. All right, so here's the command I'm going to use. The host would be the local host where I'm running the self-hosted Mongo instance. I'm providing the authentication details for the Mongo database, Mongo admin, and the password. I'm specifying which DB I intend to export with the Mongo dump command, and I'm specifying the folder where the data should be exported. All right, so that's done. Let's take a look at the content of the exported folder. All right. So here's the, so as you can see, I've specified the mflix-dump directory for the Mongo dump export. It has created a database, it has created a directory for the database and created the BSON files, which are the dump files, for each one for each collection. So I have 5 collections and there are BSON files for each collection. And there are some JSON files that contain metadata related to the collection, but this is the main data set. All right, so that was easy. Let's see how we can restore this data. And MongoDump can also be run for one collection. So there is that option. In this case, I've just run it against the whole database, but you can run it against a collection. So while restoring, I'm going to use this restore command. In this case, my restore is going to be the target Cosmos DB account, and I'm providing the username and password of the Cosmos DB account. This will be available from the connection string blade in the portal. And this time I'm specifying a different DB name. I want to keep the data migrated from each of these migration methods in separate databases just to avoid any conflicts. So the data migrated from database migration service is in the sample mflix database. So for migrating with the native tools, I'm going to create another database called mflix native. So I'm just specifying the target DB name over here, and the command will take care of creating the missing database in the background. I'm restoring one collections out of these exported dumps over here. I'm restoring the theaters collection, and I'm specifying the bson file to restore the data from, right, which is the file created over here. So let's run that. And if we switch back to the portal, we should see the sample mflix native database added now. There it is. And the data, the theaters collection, and the data inside the collection. Yeah, so the command has finished, and we should be seeing the data over here. Okay, yeah, there it is. Perfect. So we looked at Mongo dump and Mongo restore. Now let's perform migration using Mongo export and Mongo import as well. So this is a sample command for Mongo export. Once again, the host is the source, which is my local host. So I've specified that, and I'm specifying the credentials once again, um, the database name to export from, and this time I'm exporting a single collection. So I'm exporting sessions collection, and this is the JSON file to which data will be exported. And that's done. Let's look at the output, and here it is, sessions.json, right? So I'm going to import this collection into my Cosmos DB account now using Mongo import command. Once again, the host is my target Cosmos DB account, and the credentials are my Cosmos DB credentials. I'm specifying the sample mflix native DB once again for the target, and I'm specifying the sessions collections which I just exported in the previous command. And that's done. So let's switch back once again to the portal, and now we should see a sessions collection added over here. There it is. All right. This is a small collection, so it just has one entry, but the data is migrated already. All right, so those were the native MongoDB tools that you can use. And like I said, you can use these utilities are also built into Studio 3T and RoboMongo. So you can use that from those tools as well. The only caveat, and I'll switch back over here for a minute, is these native MongoDB tools are not familiar with the throughput limitations of Cosmos DB. So you need custom handling for throttles. Uh, these this client will not do that automatically in the background for you, unlike database migration service will, right? So with Mongo import command, for example, you can control the number of batches, the number of workers that you run to control the speed of the import process. So that's something that you need to figure out and take care of, depending upon the size of your data set and the throughput that you have set for your target Cosmos DB account. The last migration method I'm going to cover today is the Azure Data Factory. So Azure Data Factory is fully managed serverless data integration service that's available on Azure. This also makes use of the Cosmos DB bulk executor library in the background and is suitable for performing migrations of large datasets. So how do we perform migration using Azure Data Factory? So these are the steps involved. We need to create a source dataset in the Azure Data Factory UI, then create a target dataset, create a data transfer pipeline again in the ADF UI, publish resources, trigger pipeline, and then monitor the progress and status. So let's switch back to the portal, and this time I'm going to go to an Azure Data Factory resource that I have created for demonstrating this migration. So this is my Azure portal or the ADF resource, and I'm going to click on author and monitor over here, and this will take me to the Azure Data Factory UI. So what I'm going to do today is just perform a simple migration using the Azure Data Factory mode and from the portal itself. So I'm going to click on the author blade over here. And so as you can see right now, there are no resources in this factory. And like I said, I'm going to create two data sets, one for the source, one for the destination, and one copy pipeline. So let's start with creating a new data set corresponding to the source. So my source is a self-hosted MongoDB, and so I'm going to choose this data store, MongoDB, click on continue, and I'm going to create a new linked service here. I'm just going to leave the name and the integration runtime name default. I will specify the connection string for my self-hosted Mongo instance. And if I uncheck this, it's going to fetch the database names available at the source and auto-populate that. So it'll just give me an extra step of verifying that the connection string is right and that it's able to talk to it. So this is my database name. I'm going to choose that for the source. I can also click test connection over here just to make sure everything is well and create the new linked service. So this is my source linked service, and I'm going to choose the collection which I'm going to migrate. Let's go for theaters collection. And yeah, so that completes the dataset creation for the source. Now I'm going to also create another dataset for the destination Cosmos DB account. So I'm going to go ahead, click on new dataset, and this time I'm going to choose Cosmos DB. And I need Azure Cosmos DB Mongo API data store. So continue. Once again, create a new linked service. I'm leaving the name as it is, integration runtime. I'm just going to select the subscription that I need to migrate to and going to pick the target Cosmos DB account name here. All right, so one consideration with Azure Data Factory is that in the other two methods, we did not manually go and create the databases at the target. The service just did that in the background. That doesn't happen with ADF. Now, like I said, I want to keep the data migrated using the three migration methods in three different databases. So let me go ahead and create a database here for ADF migration. So I'm going to create a database called sample mflix ADF, not assigning any provision throughput to it. And once this gets created, I also need to create a collection inside it. So I'm going to migrate the theaters collection. I'm going to choose fixed and click on OK. So now we have a sample mflix ADF database, which will be the target for the migration, and there's an empty collection inside it, right? I'm going to go back and refresh the database list over here. And here's the ADF DB that I just created at the target. Test connection, successful. And I'm going to create this linked service now. Okay, so the linked service for the target is now created. And I'm going to specify, I'm going to choose the collection name, which I also created manually at the target, the theaters collection. And that completes the creation of both the data sets, right? So the next step is going to be to create the data pipeline. So I'm going to click on new pipeline over here, expand, move, and transform, and drag over this copy data activity to the center. I'm going to perform a simple migration. So most of these settings can be as is, and I'm going to just select the source data set, and this would be the MongoDB self-hosted instance data set that I just created, and the sync data set, which is the target, which would be the Cosmos DB Mongo API, right? And rest of the settings I'm going to leave as is. And the next step I'm going to need to do is publish these resources. So I have three factory resources now, two data sets and one pipeline. So I'm going to publish all of them because only once I publish will it allow me to trigger the pipeline. All right. So the ADF resources have been published now. Now I can click on add trigger and trigger the pipeline. It's going to just pick the last published changes and trigger the pipeline in the background. And once the trigger is completed, I can click on view pipeline run over here. It'll take me to this monitor blade pipeline runs, and it shows me the progress of the data transfer that I just started, right? So as you can see, the data transfer is currently in progress, and it's copying data. We can click on this icon to view more details, and usually this completes quickly for a small collection. So here it is. Yeah, the status has succeeded. The data transfer for this collection that we just set up has completed, and we can view the statistics in the details right here. All right. And once again, if we refresh this theaters collection, we should now see the data migrated over using the Azure Data Factory. There it is. So a few considerations I would like to talk about while using Azure Data Factory is, like we saw, the pipeline needs to be created for each collection. Um, there is lack of checkpointing, which means if there is a failure at any step during the migration, it will not resume, or there's no option to resume. You have to start the pipeline all over again. There's a lack of dead letter queue, which means the entire transfer will fail if there is a problem with a single item. And lastly, the indexes cannot be migrated. So Data Factory was built for data transfers, not for one-time migration. So it doesn't take care of indexes in the background because that's not what the feature or the service was built for. But despite that, there might be scenarios where you might find using Data Factory helpful. So we have seen that customers do prefer it sometimes. So that's how you can perform the migration using Data Factory, right? So that covers the three migration methods that I wanted to cover. And like I said, the last step is the post migration steps. And really, the only mandatory step over here is to change the connection string in the application. Rest all are optional. So, depending upon what you have decided in the pre migration stage, you may choose to optimize the indexing policy. So, in my case, I do need to optimize the indexing policy. So let me go ahead and just completely switch over to a Cosmos DB, switch over my application to Cosmos DB. So what I need two wildcard indexes for two of these collections. So I'm going to go ahead and save those. So yeah, those were pretty much the only changes which I wanted to do for this application. But you might choose to change the consistency levels. We have 5 different consistency levels available. You may need to configure geo replication. So typically, we recommend not to enable geo replication before performing the migration, because that will just incur more charges while the data is being migrated over. So you can configure the replication to other regions after the migration has been done. And you can choose to, for example, enable automatic failover to these other regions if you want to. So these are a few Cosmos DB features that you can make use of, and these are very easy to set up from the portal itself. Apart from the Cosmos DB features, there is good integration with the other Azure services. Like, for example, you can use Monitor to performance to look at the metrics and log analytics and to track the performance of the database. The backups are also enabled by default, but you can customize them further. You can choose the retention and the number of backups retained as per your requirement. You can choose and tweak the networking settings, for example, firewall and private endpoints, and yeah, to make your application more secure. And you can use built-in Jupyter and C# notebooks to further enhance the experience of working with your application and database. Having said that, the indexes which I created should now have been populated. So let me go ahead and switch my application over to Cosmos DB now. Okay. So I'm going to connect to the terminal where my application is running. All right. So um, I'm connected to the machine where the demo app is running, and I'm going to switch over here and I'm going to change my connection string from the self-hosted MongoDB instance that it's pointing to Cosmos DB. Right. Let's save that. And I'm just going to reload my application. And there it is. So the migration is done. The application is moved over completely to Cosmos DB. And that's all I had for today. I hope this session gave you a good overview of the migration steps and the process, and gave you a good overview of the 3 migration methods that I demonstrated. And I hope this it helps you make a decision on which migration methods you would like to choose for your application. That's all I had for today. Thank you and have a good day.